Have you ever wondered where white dwarfs come from? These celestial bodies are the remnants of stars, much like our own sun, that have exhausted their primary nuclear fuel. They are the end products of a fascinating cosmic journey, and understanding their formation requires a step-by-step walk through the life of a star. Imagine, if you will, a star born with a mass less than about 8 times that of our sun. This star lives its life by fusing the hydrogen within its core into helium. This nuclear fusion generates an immense amount of heat, creating an outward pressure. Picture it like a pressure cooker, with the heat of the fusion acting like the fire beneath, and gravity acting as the sealed lid on top. In about 5 billion years, our sun will exhaust all the hydrogen in its core. The balance between pressure and gravity tips in favor of gravity, and the star begins to collapse. However, this compression causes the star to heat up again, enabling it to fuse the remaining hydrogen in a shell around its core. This process expands the outer layers of the star, transforming our sun into a red giant. As a red giant, our sun's core temperature increases until it's hot enough to fuse the helium created from hydrogen fusion, transforming it into carbon and other heavier elements. However, this stage is relatively short-lived, lasting only about 1 billion years compared to the nearly 10 billion years it spent burning hydrogen. But what happens next? Well, our red giant sun continues to consume helium and produce carbon. But when it runs out of helium, it isn't quite hot enough to burn the carbon it has created. This lack of fuel causes the star to succumb to gravity once again. The core contracts, releasing energy that causes the star's envelope to expand even further, making it an even bigger giant. At this point, the sun's radius would be larger than the Earth's orbit. The sun remains in this unstable state, losing mass until it finally blows its outer layers off. The core, however, remains intact and becomes a white dwarf. This white dwarf is surrounded by an expanding shell of gas, in an object known as a planetary nebula. These nebulae are so named because early observers thought they resembled the planets Uranus and Neptune. In summary, a white dwarf is the core remnant of a medium-mass star that has exhausted its nuclear fuel. It is the end result of a delicate balance between pressure and gravity, a cosmic dance that takes billions of years to complete. These dense, hot celestial bodies are a testament to the cyclical nature